Health, Safety, and Environment 3. Module 1, Contractor Employee HSE, Risk Management, and Offshore Safety. 1. Introduction to the course. Welcome to this advanced level in our Health, Safety, and Environment series, HSE 3. In this module, we are going to explore key elements of safety management that are not only critical for compliance but also for sustaining life, protecting the environment, and ensuring the smooth running of high-risk industries, especially oil and gas. As we progress, we will understand how contractor employees are integrated into an organization's HSE framework. Examine risk management techniques, particularly those applied in oil and gas operations. Review historical offshore disasters and the lessons they have taught us. Discuss how incidents are recorded and analyzed. Learn about permit-required confined space entry procedures. By the end of this module, you should have a clear understanding of both the theory and the practical application of these principles, and you should be able to explain why each one is crucial in keeping people and operations safe. 2. Contractor Employee HSE. Let's start with a reality check. In modern industrial projects, especially in oil and gas, much of the work is not done by the company's own employees but by contractor employees. These are individuals or teams hired by an external company to perform certain jobs: drilling, construction, maintenance, logistics, and more. The challenge is that contractors often come from different backgrounds, different safety cultures, and different levels of training. Integrating them into your HSE system is essential. Why contractor HSE is critical. Contractors may be unfamiliar with the specific hazard at your site. They might not have the same safety priorities as your organization. An incident involving a contractor still impacts your company's record, reputation, and possibly its legal standing. Key elements of contractor HSE management. Pre-qualification and selection. Before bringing contractors on board, evaluate their safety records, training programs, and incident history. Induction and orientation. Every contractor employee should go through a site-specific safety induction that covers hazards, emergency procedures, and reporting protocols. Monitoring and supervision. Contractors should be regularly audited to ensure they follow site rules and use protective equipment correctly. Communication. Open channels between contractors and your HSE department prevent misunderstandings and promote safety culture. Performance evaluation. Keep track of contractor HSE performance and give feedback for improvement. 3. Risk management techniques in the oil and gas industry. Risk management is the backbone of safe operations, especially in high-hazard industries like oil and gas. The basic idea is simple: identify hazards before they cause harm, assess the likelihood and severity, and then take steps to control them. But in practice, risk management is a structured, ongoing process. Step-by-step risk management approach. Hazard identification. Look for anything that could potentially cause harm, from mechanical failures to human errors. Risk assessment. Evaluate each hazard in terms of how likely it is to happen and how serious the consequences would be. Control measures. Implement steps to either eliminate the hazard or reduce the risk to an acceptable level. Monitoring and review. Risks change over time, so continuous reassessment is critical. Common techniques used. Job hazard analysis, JHA, breaking down a job into tasks and analyzing risks at each step. Hazard and operability study, HAZOP, a team-based method for identifying potential problems in system design. Failure mode and effect analysis, FME, identifying ways equipment can fail and how to prevent them. BOTA analysis, visualizing the causes and consequences of a hazard with preventive and recovery measures. 4. Basic offshore disasters on record. Learning from history is one of the best ways to prevent future incidents. The offshore oil and gas industry has faced several major disasters that have shaped safety standards. Notable cases. Piper Alpha, 1988. A catastrophic platform explosion in the North Sea killed 167 workers. The main cause was inadequate maintenance and poor communication during shift changes. Deepwater Horizon, 2010. A blowout in the Gulf of Mexico caused 11 deaths and the largest marine oil spill in history. Investigation revealed failures in well design, testing, and decision-making. Alexander L. Killand, 1980. A semi-submersible drilling platform collapsed due to a structural failure, killing 123 people. This incident highlighted the importance of structural integrity inspections. 5. Recordable cases and HSE calculations. In the HSE field, incidents are classified to help organizations track safety performance. Types of recordable cases. Medical treatment cases require treatment beyond first aid. Restricted work cases, the worker can only perform limited duties. Lost time cases, the worker cannot return to work for a period. Fatalities, loss of life due to work-related causes. HSE calculations, such as incident rates, help measure safety performance over time. While we won't use formulas here, know that these calculations compare incidents to the total hours worked, giving a standardized view of performance. 6. Permit required confined space entry. Confined spaces are areas with limited entry and exit points, not meant for continuous occupancy, and with potential hazards like toxic gases or low oxygen. Permit system. Before entering, a confined space entry permit must be issued. This document confirms hazards have been identified. Safety measures are in place. Rescue plans are ready. The space has been tested for safe atmospheric conditions. No entry should occur without a valid permit, and only trained personnel should perform the work. 7. Risk management revisited, continuous improvement. Risk management is not a once-and-done process. In oil and gas, operational conditions change, new hazards emerge, and people change roles. Continuous improvement means regularly updating risk assessments, conducting refresher training, learning from near misses as well as actual incidents. 8. Emergency Response Plan, ERP. An ERP is a structured approach to dealing with emergencies to minimize harm to people, the environment, and assets. Key components. Preparedness, identify potential emergencies and plan ahead. Response, clear actions to take when an emergency happens. Recovery, steps to restore normal operations. Communication, ensuring the right people are informed at the right time. Regular drills make sure everyone knows what to do. This brings us to the end of Module 1. In Module 2, we will explore first aid, security management, safe handling of chemicals, journey management systems, and tie them into a comprehensive approach to health, safety, and environment in industrial settings.